The idea that our reality isn't what it seems has captivated thinkers for centuries. Simulation theory proposes a bold hypothesis. Our universe might be a sophisticated computer simulation. Prominent figures in science and technology have seriously considered this possibility. If we can eventually create simulated worlds, does that imply we might already be inhabiting one? The core of simulation theory rests on the premise that an advanced civilization could create a universe indistinguishable from reality. Inhabitants of this simulation, like us, would be unaware of their simulated nature. This raises profound questions about the nature of reality, our existence, and the limits of our perception. Quantum mechanics presents a compelling case for the simulation hypothesis, a theory suggesting our reality might be an artificial construct. The bizarre behavior of quantum particles, like superposition and entanglement, defies classical physics and challenges our understanding of the universe. Superposition suggests a particle can exist in multiple states simultaneously until observed, a concept that seems almost magical. Entanglement links two particles instantaneously, regardless of distance, as if they share a hidden connection. These phenomena hint at a reality that is not as concrete as it appears, suggesting layers of complexity beyond our perception. The observer effect states that observing a quantum system influences its outcome, implying our role in shaping reality. Could this be evidence of a simulated environment, where observation triggers the rendering of reality, much like a computer program? Imagine a video game where only the areas currently being viewed by the player are rendered in detail, conserving computational resources. Perhaps our universe operates on a similar principle, with reality materializing when observed, a concept that blurs the line between science and science fiction. The concept of a simulated reality isn't entirely new. Throughout history, various philosophies have explored the idea that what we perceive might not be the ultimate truth. Plato's Allegory of the Cave describes prisoners mistaking shadows for reality. These shadows are mere reflections of the true forms, which the prisoners cannot see. This allegory mirrors the simulation hypothesis, suggesting our perception might be a limited representation of a deeper reality. Just as the prisoners see only shadows, we might be experiencing a filtered version of the true essence of existence. Similarly, the Hindu concept of Maya describes the world as an illusion. According to this philosophy, what we see and experience is not the ultimate reality, but a veil that obscures the true nature of the universe. This ancient philosophy resonates with the simulation theory, implying our sensory experiences might be deceptive. The idea that our senses can be fooled aligns with the notion that we might be living in a sophisticated simulation. Consider the limitations of our senses. We perceive only a narrow band of the electromagnetic spectrum. Our eyes can only detect visible light, missing out on a vast array of information. Just as the prisoners in Plato's cave are limited to perceiving shadows, we too might be limited by our sensory apparatus. Our understanding of reality is constrained by the tools we have to perceive it. This analogy reinforces the idea that our perception might be a filtered version of a more complex underlying reality. The layers of reality we experience could be just the surface, hiding a deeper, more intricate truth. String theory proposes that the fundamental building blocks of the universe are tiny, vibrating strings. One of its most remarkable implications is the holographic principle. This principle suggests that the information describing a three-dimensional volume of space can be encoded on its two-dimensional boundary. This aligns with the idea of a simulated universe, where space might be a projected illusion. Imagine a holographic image appearing three-dimensional despite being encoded on a two-dimensional surface. Similarly, our universe might be a holographic projection. The holographic principle offers a potential solution for storing the information of a vast universe efficiently. The universe exhibits a remarkable mathematical order. From the orbits of planets to the structure of atoms, mathematical equations describe the fundamental laws governing the cosmos. This inherent mathematical structure suggests that the universe might be based on a sophisticated mathematical code. Just as a computer program operates on lines of code, our universe might be governed by a set of underlying mathematical equations. Consider the Fibonacci sequence, a mathematical pattern found throughout nature. This recurring pattern suggests a deep mathematical order inherent in the natural world. The mathematical underpinnings of reality might be the key to understanding the nature of the simulation. Consciousness, the subjective experience of awareness, remains one of the greatest mysteries of science. Could consciousness be the interface through which we interact with the simulation? Some proponents suggest that consciousness might be a fundamental aspect of the universe. Perhaps the act of observing triggers the rendering of reality within the simulation. Consider the phenomenon of lucid dreaming, where the dreamer becomes aware and can control the dream. Could our waking reality be a form of shared lucid dreaming? The interplay between consciousness and reality remains a fertile ground for exploration within the context of simulation theory. The implications of living in a simulated reality are profound and far-reaching. If our universe is indeed a simulation, it challenges our understanding of free will, existence, and the meaning of life. Does free will exist within a predetermined program? The ethical implications are equally significant. If we are living in a simulation created by a more advanced civilization, what are our obligations to our simulators? These questions delve into uncharted ethical territory, prompting us to consider our place in a potentially larger cosmic hierarchy. The question of whether we are living in a simulation remains unanswered. This idea, popularized by philosophers and scientists alike, has sparked countless debates and discussions. The convergence of ideas from computer science, quantum mechanics, philosophy, and string theory provides compelling food for thought. Each field offers unique insights that, when combined, paint a fascinating picture of our potential simulated existence. The simulation hypothesis challenges us to question our assumptions about reality. It forces us to consider the possibility that everything we perceive might be an intricate illusion created by advanced technology. Even if we can never definitively prove or disprove the simulation hypothesis, pondering it expands our intellectual horizons. It encourages us to think beyond the conventional boundaries of science and philosophy. The search for truth, whether within or outside a simulation, is a fundamental human drive. This quest for understanding is what propels us forward, pushing the limits of our knowledge and imagination. As our ability to create virtual realities increases, the line between the real and the simulated becomes increasingly blurred. The advancements in virtual reality technology make the simulation hypothesis more plausible and intriguing. The exploration of these questions is a testament to the human capacity for wonder and the relentless pursuit of understanding. It highlights our innate curiosity and our desire to uncover the mysteries of existence, no matter how complex they may be.